this unit is, we're in the triangles unit. And now today we're going to focus on two of the most special triangles. They're like celebrities, isosceles and equilateral triangles. And although you do not have to memorize the roots of these words, it's kind of nice to know where they come from. So in the word isosceles, the iso means same, and the skelos, where the sceles comes from, means leg. So isosceles means same leg. Equilateral, we talked about that yesterday, means equal, and then lateral means sided. So a shape, a figure, a triangle that is equal-sided. So that's what equilateral is. We're going to start today's lesson by constructing. Instead of ending with constructing, we're going to start with it. This is going to be one way to construct an isosceles triangle. On your homework today, alright, so to construct an isosceles triangle, which like I just said, you're going to do it a different way on your homework. There's more than one way. We're going to do the easiest way there is in class. I want you to use your straight edge, and I want you to draw an angle. The beauty is it can be any angle you want. I want this one to be acute, though. Let's start with an acute one. Label your angle A. So you're going to label the vertex of your angle A. Make sure you use a straight edge. We don't do constructions with a free hand. You've titled your notes Isosceles and Equilateral, and you've drawn an acute angle. So our job is to take this angle and to ensure that when we make a triangle out of it, it has two sides congruent. And of course, you know that when we do constructions, it's all based off of radii of circles. All of our constructions are based off of congruent circles have congruent radii. Or within the same circle, all the radii are congruent. So we're going to use our knowledge of that, and we're going to use that tool, and we're going to take our compass and put our needle on the vertex of that angle, and we're just going to make an arc. You do that. Make an arc. That arc, make sure that it intersects your angle twice, and that will be the vertices of the other angles of the triangle. So make one single arc, make sure it hits your angle twice, then use your straight edge and connect B to C. Draw segment BC. You now, of course, have an isosceles triangle, and I want you to mark the sides that are congruent. You might not have patty paper out, but if you did have patty paper, you would simply confirm that it was isosceles by tracing that segment and then moving your patty paper over and confirming that it is perfectly congruent to that segment right there. Which sides are congruent when you use your patty paper to test? Add tick marks to your picture. No, you don't have to erase anything, Hatham. Don't worry about it. Which sides are congruent? So we can name them, right? We could write a congruent statement. This is called a congruent statement. AC is congruent to AB. Yep. Could you have constructed a triangle that was not just isosceles, that was equilateral? Could all three of your sides be congruent? That's an easy question. The harder question is, when would that happen? What would have had to happen? Ooh, Sharon got it right away. Didn't even give you time to think. Okay, so all three of the sides could have been congruent if your angle that you started with was a 60-degree angle. And I'm going to leave it at that. We're going to talk more about that later in the lesson. Which angles are congruent? If you go back to your construction, and if you had patty paper and you traced angle A, and you moved it over and compared it, oh no. Is angle A congruent to angle B? No. But if you traced angle B and you compared it, let's see, flip, left, right. Oh, that's beautiful. So angle B is congruent to angle C. And that is a theorem. Woohoo! We just came up with a theorem. It is called the Isosceles Triangle Theorem. You don't need to write this in your notes because this is on that big paper called Notes from Proofs, where we keep all of our theorems for the whole semester. There's 46 of them just for the fall semester. We are so smart people. We are learning all of these. All right, so the Isosceles Triangle Theorem says if two sides of a triangle are congruent, so that's the hypothesis, that has to be true, then the angles opposite those sides are congruent. So you draw an arrow away from your angle, or sorry, your side. Draw an arrow away from your sides, and those angles that you're pointing to are the same measure, are congruent. What about the converse of this theorem? What would the converse of this theorem be? And would it be true? If two sides are congruent, then the angles opposite are congruent. So the converse would be if two angles of a triangle are congruent, so you're given A and B, then the sides opposite are congruent. So of course the converse of the theorem is true as well. That's how theorems work. So we know that AC is congruent to BC. We can add tick marks. So if you have arcs, you get to add the tick marks. If you have tick marks, you get to add the arcs, and that's how that works. All right, so we have 3 examples here. Isosceles or not? Let's look at these. First triangle, triangle A. Does the isosceles triangle theorem say that that is isosceles or not isosceles? No, and of course, why not? Because it doesn't have congruent angles. Correct. What about B? Is B isosceles? Check. And could you identify the congruent sides? It's important that you can find those congruent sides. Really important. All right, what about C? Ready, set, go. No. And what step did you have to complete to be able to answer that question? What did you have to do? Good, the triangle sum theorem. I love it when you say theorems. You had to add those up and subtract from 180, and you got 76 degrees. So although that triangle looks perfectly isosceles, we do not assume. We find the missing angle, and we say, nope, the evidence points to no. The picture lies. That's right. We lie with pictures all the time. Okay, in your notes, I would like you to, well, actually use that isosceles triangle you already constructed. Use that one, and we are going to label the parts of an isosceles triangle. Triangle anatomy. Let's start with the easiest one. The two sides that have tick marks, what are those sides called? Sharon first, good job. Those sides that have tick marks, it's trying to, there we go, are called legs. Awesome. What is the side called that does not have a tick mark? Awesome. The side that does not have a tick mark is called the base. So an isosceles triangle has one base and 2 legs. One base and 2 legs. Okay, what are the angles that surround the base? Use common sense. What are the angles that surround the base? We're not finding volume or area right now. Stop it. Hey, Sharon is right again. The angles that surround the base are called base angles. That's so cute that y'all said same side interior. That is so cute. Okay, base angles. Very good. They are same side interior angles, but we're not going to use that. Okay, Joseph. And what is that last angle called? The angles where the 2 legs intersect. The last angle. Yes, Jesselyn, good job. The vertex angle. So it's important to know what the parts of an isosceles triangle are called because I'm going to be calling them that over and over. Okay, I want you to actually draw these in your notes. Do you see what I did here? Draw triangle TRI and triangle ANG. Triangle. I didn't have room for the LE. But anyway, draw those two, and I want you to, in the first one, name the base angles, and in the second one, name the legs. I will call on you. Do not type it. Let's go over these. So what students struggle with a lot is that they have trouble identifying the legs and the base angles when the triangle isn't like perfectly upright, like this is the vertex and these are the bases. So if you were given the information that TR and RI were the legs, if those were the congruent sides, the Isosceles Triangle theorem says that the angles opposite are the base angles. So the base angles are T and I. Very good. T is congruent to I. In our next triangle, it says A and N are the base angles. Name the legs. So you look across from the base angle. So the legs would be AG and GN or NG. Awesome. We're going to construct an equilateral triangle now, and this one is a little bit more complicated. There's also multiple ways to do this, and you can look up the other ways if you just really want enrichment over the weekend. So when we construct an equilateral triangle, of course, it's going to be dependent on radii again, on a radius of a circle. So I want you to start by placing a point on your paper, call it A, and construct a circle with A as the center. Go. Now, the key to this construction is step number 2. The key to this construction. So, when you do step 2 of the construction, you're going to make another circle. It needs to be identical to your first one. It needs to be congruent to your first one. But this second circle needs to pass through point A. So, the key to that is put your pencil on A. See how the pencil is on A, not the needle anymore. Put your pencil on A, and then let your needle fall wherever you want it to fall. And then construct a new circle. This circle needs to pass through point A. So you're going to have like a Venn diagram. You're going to have your 2 overlapping circles. These 2 circles, they will intersect. How many times will they intersect? 2 times. You got it. Pick either one of those intersections. Pick either one of those intersections and call it C. And then you simply connect A to B, B to C, and C to A. All of those are radii of the same circle. If you're a radius of the same circle, you have the exact same length. So it's pretty cool. Create an equilateral triangle using the fact that radii are congruent. Yay! I'm going to move on. You can practice at home. It's beautiful. How do we know it's equilateral? We talked about that with the radius. Could you, if I told you the sides need to be 2 inches long each, could you construct it with a given side length? Of course you could. Your initial radius, when you put point A there, and you open your compass would need to open however long you wanted the side lengths to be. What are the measures of the angles? Measure of angle A, measure of angle B, measure of angle C. Of course. So in an equilateral triangle, the angles must be, have to be, are always 60 degrees. All right, easy, easy. Equilateral triangle theorem. If a triangle is equilateral, then it's equiangular. Yay! Converse. If a triangle is equiangular, then it is equilateral. And that is on this sheet, which is why I'm not giving you enough time to write it down. Here is that theorem in pictures. I just thought it'd be fun. If all sides are congruent, then all angles are congruent, and they equal 60 degrees. If all angles are congruent, then all sides are congruent. Okay, we have 2 examples, and then our lesson is over. Please find the measure of the missing angles. Because we're running short on time, I'm just going to start working this, and you can show me that you know how to do it in your homework. We're going to use a lot of theorems here, which is so fun. Let's start by using the Isosceles Triangle Theorem. The ITT. Isosceles Triangle Theorem says if two sides are congruent, then the angles opposite are congruent. So I've now already solved for an angle. It's 22 using the Isosceles Triangle Theorem. Okay, now let's use the Triangle Sum Theorem, the TST. I'm just making this up. Don't really abbreviate those. If I can add up my base angles, 22 plus 22, and subtract it from 180, I will know my vertex angle. Angle W is 136. That's the vertex angle. That's an obtuse triangle. Yay, vocab. All right, now we're going to use the LPT. What's that stand for? The linear pair theorem. The linear pair of 136 is 44. Another way I could have gotten 44, sorry. Add these two, right? The sum of the remote interior angles equals the exterior angle. Whoa, mind blown. Okay, anyways. Now we're going to use the Isosceles Triangle Theorem again. The base angles are congruent. Alrighty, now we need to find y. We're going to use the Triangle Sum Theorem. Add 44 plus 44 and subtract it from 180. Another obtuse triangle. Yep, and now to find z, you can either do linear pair of 44. Because we've already found the linear pair of 44, we don't really need to do any extra work. Cool? Beautiful. Yes, totally. You can do the remote. Yeah, you can add 44 plus 92. Last problem of the day. What do you notice about triangle ABC? What do you notice? It's two things. It's right and it's a triangle. It's isosceles. So what is the measure of angle A and the measure of angle C? Very good. We know that it's right. We know it's isosceles. So we actually know the measure of these angles. That's not a coincidence. That will happen every time. Okay, so they give us what angle A equals and angle C equals, and they want us to solve for x and y. Well, we already know. We can use substitution. We already know angle A is 45 degrees. We already know angle C is 45 degrees. And what is that called? First an x. It's a system of equations, but it's the easiest system on earth. So we're going to not freak out about systems, and we're just going to add these together. X plus 4x is 5x. 45 plus 45 is 90. And looky there, easy stuff. 90 divided by 5 is 18. We love when we have systems and one of the variables cancels out. That's the whole goal. Now that you know x is 18, just plug it in right here. 18 plus, I don't know, equals 45. So then you're just subtracting 18 from 45. 27. Cool? Please do the homework. Please do the front and the back of the homework. I will see y'all on Monday.